In last lecture, we discussed about del operator, definition of divergence, gradient, and curl. So, what is divergence? So, here we have to take a simple example for divergence. Divergence is indicate change in magnitude of any vector quantity. Curl is indicate change in direction of any vector quantity. And what gradient is indicate? The gradient is indicate how much amount of any scalar quantity is change in x, y, and z direction. It is indicated by the gradient, not only x, y, z direction. It may be rho, phi, z, and r, theta, and phi, z direction. It depends on the types of the coordinate system. Okay, so now in today's lecture, what we have to do? In today's lecture, we have to find out the definition or the equation of divergence, curl, and gradient in all the three coordinate system. Okay, and actually this is the important thing. Because here, as we know that what is the curl? Curl means change in direction, and actually we have to deal with electromagnetic wave. Okay, so electromagnetic wave is change in which direction? Okay, or you can say by how much amount the magnitude of electromagnetic wave is change. Okay, so that is why these two definition, divergence and curl, is very most useful. Okay, so and in which coordinate, either it is a Cartesian coordinate, cylindrical coordinate, or spherical coordinate. Okay, so that is why all these three definitions are very useful, because finally we have to deal with the electromagnetic wave. Okay, so now in today's lecture, what we have to discuss in today's lecture, we will discuss about the equation of divergence, curl, and gradient in all the three coordinate system. Okay, so how to write the equation of divergence, curl, and gradient in all the three coordinate system. Okay, so I have to given one shortcut method to remember all those things. So here, first of all, we have to discuss about one most important thing, which is equation of differential line, surface, and volume in all the three coordinate system. Okay, before discussing equation of divergence, curl, and gradient in all the three coordinate system, first of all we will discuss about the equation of line, surface, and volume in all the three coordinate system. Okay, so as we know that line is a vector quantity, because line is a direction. Okay, so line is vector quantity. Surface is also a vector quantity. But what about the volume? Volume is scalar quantity. Okay, what is the unit of line? Meter. Unit of surface? Meter square. And unit of volume is meter cube. Okay, so here first of all I have to write the equation of line, surface, and volume in all the three coordinate: Cartesian, cylindrical, and spherical coordinate. Okay, so let us say first line. Okay, equation of line in all the three coordinate system. Okay, so here I have to not take the whole line, I have to just take a very small portion of the line, and it is known as the differential portion of the line. So I have to write the equation of differential line. Okay, what do you mean by the differential lines? Here I have to draw this one so you can easily understand this one, this concept. It is x, y, and z axis. Okay, so suppose one line is present. So here this one is the origin, this one is my point P. Okay, and this point P has a coordinate 2, 3, and 1. Okay, so one line which is from origin to the point P. Now this line cover how much distance in the x direction? This line cover 2 steps in the x direction, 3 steps in the y direction, and 1 step in the z direction. Okay, so actually this one is my whole line. Okay, so OP is my line. Clear? So I have to say that this capital L is indicate the length of my line. Okay, but actually I was not interested in this whole length. I have to interested in the differential length of the line. So differential length is known as DL. Okay, the differential length is known as DL, and length, as we know that the line is a vector quantity, so this length DL is also a vector quantity. Okay, so suppose instead of 2, 3 and 1, suppose the point P is x, y and z. So in this case, what is the line equation? Okay, so I can write in this way: L is equals to x ax plus y ay plus z az. Okay, because this one is my origin, and what is the coordinate of origin? 0 0 0. So L vector is equals to point P coordinate minus point origin coordinate. So we will get this equation for the line, but we have to interested in the differential line. So dl, d is indicate this one is my differential line. And what do you mean by the differential? Differential means actually I have to divide my line into a very equally small portion, and I have to consider only this one small portion. It is known as dl. So the small portion length is known as dl. So this is a differential line. So I have to write the equation of differential line in Cartesian coordinate system, in cylindrical coordinate system, and finally spherical coordinate system. Okay, so dl is equals to dx ax plus dy ay plus dz az. Okay, here this one dx means is a differential portion, okay, in x direction, differential portion in y direction, and differential portion in z direction. Just have to put here d. Okay, what ax, ay and az, these are the unit vector in x, y and z direction. Okay, so I have to write the line equation in x, y and z coordinate. Okay, so these are the line equation for Cartesian x, y and z coordinate. Next, I have to write the line equation for rho, phi and z in cylindrical coordinate system. Okay, so I have to represent using same dl is equals to here x, y, z. So dx, dy, dz. Here rho, phi, z. So d rho, d phi, dz. Okay, so it is d rho a rho plus d5 a5 plus dz az. This one is very easy. Okay, and next is r, theta and phi. Okay, so line equation in spherical coordinate system. So it is dl is equals to dr ar plus d theta a theta plus d5 a5. Okay, so all the three equations are very easy, but now the main thing is I have to just do a slide modification here. Okay, so now we have to interested the modification in this equation. Okay, so now you have to just remember one thing is wherever, okay, just you have to remember this one. Okay, otherwise the why those are come, so the proof is available. Okay, but actually you have to just remember these things. Okay, so no need to prove all those things. So we have to remember this one, where d5 term is present, we always put rho before it, and if d theta term is present, I have to put r before that. Okay, so here in the first equation d phi or d theta is not present, but in the second equation, yes, here if you notice d5 term is present. So if d5 is present, I have to put rho before that. So I have to put here rho. Okay, clear. Next, if you notice d theta is present, so if d theta is present, I have to put r before that. So I have to put here r. Now here d5 is present, so I have to put rho here. Okay, so you have to put rho, but I have to write the equation for spherical coordinate system. Okay, and in last lecture we have to derive the relationship between cylindrical and spherical coordinate system. Okay, so as we know that what is rho, okay, we know that rho is equals to r sine theta. Okay, we have to derive this equation in last lecture. So actually here d5 term is present, so I have to put rho Okay, but rho is a variable for cylindrical coordinate system, so I cannot put here because this one is the equation for, sorry, rho is a variable for cylindrical coordinate system and this equation is for spherical coordinate system. Clear? So instead of d5 I have to put rho, but rho is r sine theta, so I have to write here it is r sine theta. Okay, so now these are the equations, these are the three equations for differential line. Okay, and if you notice one more thing, in all the equation here dx, dy and dz. What is dx? dx is a length in x direction, dy is length in y direction, and dz is length in z direction. And what is the unit of length? Meter. So it is just meter plus meter plus meter. So unit remains meter. Okay, so here the unit remains meter in all the three cases. Okay, so these are the equation for differential line. Clear? Okay, now next I have to write the equation for differential surface. Okay, so second, surface. And as we know that what is the direction? Surface is also a vector quantity, and what is the direction of surface? The surface direction is always perpendicular to that. Okay, suppose I have to consider this page. This page is nothing but is a one type of the surface. So what is the direction of the surface? The direction of the surface is perpendicular to that. Okay, so this point, this pen is indicate the direction of the surface. Okay, so this one is the direction of the surface. Clear? So the surface direction is always perpendicular to the surface. Okay, so okay, those topics that we have already discussed in our last lecture. Okay, so if you notice this one, how many surface or how many planes are present actually? This one. Okay, so in Cartesian coordinate system there are the three plane or there are the three surface are present. XY plane, or you can say that XY surface, this surface. So for XY surface, what is the direction of this surface? Z direction. Next surface is YZ, this surface, YZ plane, or you can say that YZ surface. So what is the direction of YZ surface? X direction, or you can say that the minus X direction. Next surface is XZ plane or XZ surface. So what is the direction of XZ surface? Y direction is the direction of XZ surface. Okay, so the surface direction is always perpendicular to that. Okay, so now based on this concept I have to write the equation of surface, and surface is also a vector quantity. Okay, so here line is a vector quantity, and what is the unit of line? The unit of line is meter. Here surface is also a vector quantity, and what is the unit of surface? Unit of surface is meter square. Okay, so first of all I have to write the surface equation in Cartesian coordinate system x, y and z. Then I have to write rho phi z and that r theta and phi. Okay, so first equation of differential surface in Cartesian coordinate system. Okay, so now see what I have to do. I have to just write first ax, then ay, then az. Okay, so for which surface ax is its direction? Ax is the direction of which surface? Ax is the direction of yz surface. Okay, so that is why I have to write here dy dz. Okay, now if you notice in this case, what is dy? Is a differential length in y direction. What is dz? Is a differential length in the z direction. So it's length into length means meter into meter, so unit is meter square. Okay, here ay. So ay is the direction of which surface? Ay is the direction of xz surface. So I have to write here dx dz. Az is the direction of xy surface. So I have to write here dx dy. Okay, so now similarly I have to write all those things for the remaining coordinate system. Okay, so here I have to write in this way: rho, phi and z. Okay, so first of all I have to write for a rho, then after a5, and lastly az. Okay, so a rho, so it is a direction of d phi and dz surface, so it is d5 dz. Here it is d rho dz, and here it is d rho and d5. Okay, now we have to apply our concept. Where the d5 is present, we have to always substitute rho before that. Okay, so here d5 is present, I have to substitute rho. Here, yes, here it is d5 is present, so I have to substitute rho before that. So this one is the final equation for differential surface for the cylindrical coordinate system. Okay, next, spherical coordinate system equation for the surface for the spherical coordinate system. Okay, so I have to write first AR, A theta and A5. Okay, so here it is D theta, D5. Okay, here it is dr, d theta. Here it is, okay, dr, d, sorry, here it is dr, d5, and last dr, d theta. Okay, so here if you notice, d theta and d5 both term are present, rho and r both term are present, but instead of rho I have to write r sin theta. So it is r sin theta into r, so here it is r square sin theta. Here d5 term is present, so I have to put rho before that. Here d theta term is present, so I have to put r before that. Okay, so this one is the equation for differential surface. Okay, see here, there are so many numericals are asked in the exam based on this equation. Okay, so that is why these are the important for us. Okay, now see here, don't be confused about this. Okay, because I have a one direct method, so you have to just remember only one matrix and you can predict all those equations very easily. Okay, so let us see that method. So here, okay, so see here, first of all what I have to do, first of all I have to write the equation for line, surface and volume, and then we will see the final method. Okay, how to remember all the equations in a very easy way. Okay, so third is, next, number 3, equation for volume. And as we know that volume is a vector or scalar quantity, volume is scalar quantity. And what is the unit of volume? Unit of volume is meter cube. Scalar means there is no direction, so no ax, ay, az is present. Okay, so now we have to write the equation for volume in Cartesian coordinate, in cylindrical coordinate, and in spherical coordinate. Okay, so as we know that the volume is a scalar quantity, so no need to draw a arrow on dv. Okay, so in the Cartesian coordinate, dv is equals to dx dy into dz. As we know that, what is the unit of dx? What is dx? Dx is the distance in x direction, differential distance in the x direction, differential distance in y direction, and differential distance in the z direction. So meter into meter into meter, so it is a meter cube. Similarly, this one is my d rho, d5 and dz. Again I have to apply my concept. If d5 is present, I have to always put rho before that. Okay, here it is dr, d theta and d5. Again d theta and d5 both are present, so rho into r, but rho is equals to r sin theta, so this one is r square sin theta. Okay, so just finished. So this one is the equation for volume, differential volume. Now we discuss about one shortcut method. Okay, how to remember all those things. Okay, so now this method is very easy. Okay, so what I have to do, so just I have to remember this equation, the equation for line. Okay, you have to just remember this equation, the equation for line. Okay, so if you notice here in the line equation, I have to write the line equation in all the three coordinate, Cartesian, cylindrical and spherical coordinate system. Okay, so now I have to write in a matrix form, and I have to write just its coefficient. So here, what is the coefficient of dx? Here it is 1, here it is 1, here it is 1. So I have to just write the coefficient 1, 1 and 1. Here it is, coefficient is 1 for the cylindrical coordinate. Here the coefficient is rho. Here the coefficient is 1, so it's 1. Okay, here dr, so the coefficient is 1. Here the coefficient is r, and here it is r sin theta. Okay, so now just this one is for x, y, z, it is for rho phi z, and this one is for r theta phi. Okay, so you have to just remember in this way. This one is, this column is h1 column, this column is h2 column, and this column is h3 column. Okay, now you have to just remember this matrix. Now based on this matrix, okay, and this matrix is very easy, 1 1 1, 1 rho 1, 1 r sin theta. Okay, now based on this, we have to write the equation for first surface in Cartesian coordinate system. Okay, so if you notice the first term dy and dz, okay, so I have to hide this first column and do the simple product 1 into 1. So here the coefficient is 1. For the second, I have to hide the second column, okay, 1 into 1. Okay, see, I have to write the equation for the Cartesian coordinate. So I have to consider which row? Cartesian coordinate x, y, z. 1 into 1, so here the coefficient is 1. Okay, in the third case, I have to hide this h3, again 1 into 1, so here it is 1. Now equation for differential surface in cylindrical coordinate system. Okay, for the first term, I have to hide this first term, rho into 1, rho into 1, so this rho. For the second term, I have to hide this second column, 1 into 1, okay, so here it is 1. And for the third term, I have to hide h3, so 1 into rho, so this rho. Next, differential surface equation for the spherical coordinate system. For the first term, I have to hide this first column, r into r sin theta, so this r square sin theta. For the second term, I have to hide this one, okay, so 1 into r, so here it's r sin theta. Okay, so instead of rho, as we know that what is rho? Rho is r sin theta, so it is r sin theta. Okay, clear? And for the last term, I have to hide the third column, 1 into r, so it is r. Okay, and similarly for volume, equation of volume. Okay, what I have to do in this case for the volume, I have to do just a simple multiplication. Okay, 1 into 1 into 1, so here the coefficient is 1. 1 into rho into 1, so here the coefficient is rho. 1 into r sin theta, so it is a, okay, I have to do the multiplication, 1 into r sin theta, so it's r square sin theta, so I have to write the r square sin theta. Okay, so these are the equation for differential line, differential surface and differential volume for all the three coordinate system, the Cartesian coordinate, cylindrical coordinate and spherical coordinate system. So in next lecture we will study about the equation of divergence, curl and gradient. Our main goal is I want to write the equation for divergence, gradient and curl in all the three coordinate system. Okay, this one. What actually we want the equation of divergence, curl and gradient in all the three coordinate system. Okay, but to write those equation, first of all, this one is important to write the equation for line, surface and volume in all the three coordinate system. Okay, thank you.